Over the next couple of videos, we're going to be forecasting using Python. So we're going to look at some short-term methods for forecasting in this video, and then we're going to look at some time series methods in the next video. And then we'll look at measurement error. How do we see how accurate our forecasting model is? And then we have a video related to associative models as well. If you want to work along with us in the Python worksheet, please go to drstephpowers.github.io/management-in-Python. Once you're there, click on where it says forecasting. And then once it brings up the GitHub page, you'll want to click on the Google Colab button that you see right here, open in Colab. And this will then open up a Google Colab worksheet. If you want to be able to run the code, you will need to sign in to your own Google account. And if you want to amend the code, you'll need to copy it to your own Google Drive. This gives you your own personal copy to do with as you want. So I'm just going to switch over to one where I have already logged in. So in order to do the forecasting, we're going to need the pandas package and the numpy package. So we need to import pandas as PD and import numpy as NP. So that's the first thing we need to do. Then we're going to look at some short-term methods. There are a number of different short-term methods. One method is what is called the naive approach. You don't see Python code here for the naive approach because the naive approach is simply using the most recent data point and continuing it on. So for example, if we were looking at a table of data such as this one here, perhaps this is the number of complaints your company receives, and we have 4 periods worth of data. Using the naive approach, we would predict the number of complaints for period 5 to be 58. We simply take the previous period, period 4, which had 58 complaints, and we assume that number continues on into the future. So period 5 would be 58 as well. Now, perhaps you want to assume that the complaints could change. So instead of using a naive approach, you want to use an approach called the moving average. The moving average approach is an average of a certain number of historical periods. So for example, if we have 4 periods here in our data set, we might choose to look at the last 3, so period 4, period 3, period 2, find an average of those last 3, and use that to forecast for period 5. In which case, we add up the numbers 65, 55, 58, and divide by 3, and that would give us our forecast for period 5. To do that in Python, we need to first enter in our existing data. So here we're looking at the number of complaints. So let's just call it C. You can call it anything you want. C equals, and then here we have our 4 data points. And we run that, dump that into Python. And then we have the number of periods that goes with that. That's periods 1, 2, 3, and 4. To make it easy to look at and to deal with, we can turn this into a table like what you see on the screen. To do that, we use the pandas package. That's what this PD is. And we're using a command called dataframe. And so this is going to take our information, and here we have period and C, and it's going to put it into a table. So we do pd.dataframe, and then the command here, listzip, takes our information and makes each of these a column. So period is going to be a column, complaints is going to be a column. So it's going to appear in the order that you have them listed right here. And we want to make sure they have names. So let's name the columns. That's this columns equal. And then our quotes here is period is the first column's name and complaints is the next column name. And you'll notice that it creates a table that has an index. That's the first column. And the index numbering always starts with 0 in Python. So we'll create our complaints table, call it CT, and we can look at our output by simply calling CT. Okay, so here's our table. To create a moving average, we decide on the number of periods. And then we have it calculate the average for that number of periods. Now, moving averages aren't already defined in Python, so we actually have to create a definition. One of the reasons for these worksheets that I'm providing to you is that if you decide you want to do forecasting in the future for whatever role you are in, you can just go back to these worksheets and just copy the code for whatever data set you're dealing with. We've already figured out what the code should be. All you got to do is pop in the new information. So we're going to define the moving average here. So we have a definition. We give it a name, moving underscore average, and then we specify what the inputs are for this definition, what you have to give it in order for it to do the calculation, for example. Here we're going to give it data, and then we give it a number of periods. What it does then is it will first calculate the weights. Now, this is kind of a strange way to do it for a moving average because a moving average assumes equal weights, right? We took 3 numbers and we just found the average. But we're using this definition here worded the way that it is because we want to use a very similar form of the definition when we get to the weighted moving average. The weighted moving average is slightly different from the moving average in that it puts more emphasis or weight on a certain period. So for example, we could have a weighted moving average that's also 3 periods, but put more emphasis on the most recent data point. For example, we could take a weighted moving average of 3 periods. So here's our complaints for period 4, 3, and 2. And we could put a 50% weight on the most recent data, period 4, and put less and less weight on the older data as we go back in time. Since we want to use a similar definition for the weighted moving average as we do the moving average, that's why our definition here is not as clear cut as you might expect. So let's walk through what it says. It says define the weights. It's going to repeat using NumPy. It's going to repeat the number 1, and it's going to do that for however many periods you specify. So if we're doing a 3-period moving average, it's going to take the number 1, repeat it 3 times, and each of those ones it's going to divide by 3. So what it's saying is that it's going to take the last 3 periods here, and it's going to weight this one 1/3, this one 1/3, this one 1/3, right? That's what an average is. It adds the 3 together, it divides by 3. It's the same thing as weighting each one of 1/3. So it's going to then do that calculation with those weights. It's going to return that information. So you don't actually have to do anything to this definition. You can keep it exactly as is, because when you call the definition, that's when you're going to specify what the data is and how many periods you're going to have. So let's call it MA, just give it a name. And we're going to call the definition moving average. And then we have to specify the data and the number of periods. The data in this case is our complaints table with the column complaints. So that's what this means here. CT, and then the hard brackets and the parentheses are around the column name. And we're going to do 3 periods. So let's run that. Then we can call that MA to get the different moving averages. So the first moving average it calculates is actually for the first 3, 60 plus 65 plus 55, all equally weighted, gives you an average of 60. That's what this number is here. And then it takes the next 3, 65 plus 55 plus 58, adds those up, divides by 3, or multiplies each times 1/3, and you get a moving average of 59.33. So for our period 5, if we're using the moving average, we would forecast that for period 5, the number of complaints will be 59.33. Now, what if we want to go further in the future than just 1 period? So we have periods 1 through 4. You just forecasted period 5, 59.33. What if we want to go even further in the future? So we create a loop, and that loop needs a start and an end. And we actually want it to start forecasting not here in period 4, but we want it to start with period 5. So I actually need to change this from period 4 to period 5. And then you decide how far out into the future it goes. So I've just set it here at 15. Then what you're doing inside of your loop is that it's going to go and find the moving average from the complaints column of your CT table. It's going to do a 3-period moving average, and it's going to keep doing those calculations as it moves through. So it's temporarily going to create a data frame, a table, and then it's going to add this information to the existing table. So that's what this is here. This concat is concatenating, it's adding it to it. It's going to add to our existing table, which has this here. It's going to add additional periods and the new forecasted complaints. In order to do that, we first have to temporarily create a data frame that contains that information. And then the last piece here is simply to call the new table. So we run this, and you'll notice here, here's our original table, 60, 55, 55, 58. That's our original data. And then our forecast for period 5 was 59.33. And then it keeps going. So it takes 55 plus 58 plus 59.33, divides by 3, and gets 57.44. And it keeps going. 59 plus 57.4 plus 58.25, divide by 3, gives it 58.34. And it keeps going. You'll notice here we've told it to forecast. Now when you have a range, it's just before the last number. So the way Python does ranges is it doesn't go to 15, it goes to right before it. So it doesn't include 15. It's including 5 all the way up to, but not including 15 is how a range works in Python. So we are going from 5 here all the way up to, but not including 15. And I've included quite a bit here because I want you to see that when it comes to a moving average, after you get a couple of periods into the future, notice that the numbers stop changing. And that's because you're no longer using actual data, you are now using forecasted versions of forecasted versions. And so it just becomes a naive approach after a couple of forecasts into the future because your forecasts are based on forecasts. There's no longer any real data attached to it. Okay, so we could use this loop to help us forecast using the moving average. If you're going to do this with your own data set, all you have to do is change the range, starting with what point you want to forecast in the future. So this is going to be right after your table ends, and how far into the future you're going to go. This is one number more than the forecast it will give you. Tell it what table and column to forecast from and how many periods. And then here you just need to make sure your column names match what you are adding to. So you'll notice this period and complaints here matches the table itself, which says period and complaints. Okay, and then it concatenates. And so we need to make sure that we have CT here and CT here to match the table that it's getting added to, or else it will pump out an error for you. Okay, so there we have the moving average. Now, what if we are missing information? So let's suppose that our data looks like this. So here is our complaints. You'll notice that there is an NaN in here. And we've extended it now. We have 8 periods. So let's just put it into a table so it's easy to look at. So here we are entering our complaints, entering our periods, using that data frame list zip in order to turn it into a nice, easy to read table. Okay. So notice that we have a missing value here for period 5 or index 4. Index 4, period 5, it says NaN. So what do? Well, we need a way to fill in that spot because when it's going to calculate a moving average, it'll pop out an error if it does 55 plus 58 plus missing information divided by 3, or 58 plus missing information plus 40 divided by 3. Now, we might feel like, well, let's just put a number in there, right? The challenge, of course, is that any number that you pick can bias the results if it's not grounded in a rationale as to why that number could realistically be that. Because if you put a number, for example, if we make this really high at 80, it'll make the average much higher, and future moving averages will be higher as well. If we make this really low, right, it'll make the average lower and future averages as well. So anytime you put information in, you're adding bias. You're pushing it one way or the other, which may not be grounded in fact. We can see here for this one, we have our complaints table, column complaints, and we can say, okay, give us index 4. So you can see this is the one that has the NAN. Okay. Now what do we do about that? Well, instead of just making up a number that goes into that spot and adding bias, the best approach is to use the same method you're going to use to forecast the future to forecast the missing information. And that's because each forecasting method has different assumptions. The naive approach, for example, assumed that nothing changed. The moving average assumed there was a little bit of change. So when you start mixing different forecasting methods all into the same one, your assumptions are conflicting, right? They're two different assumptions and they both can't hold true. You can't have an assumption that things are not changing and things are changing. So it's better to use the same forecasting method to fill in the missing pieces as it is to forecast forward. So how do we do that? Well, we can create a loop here, and our loop can go and we can loop through our material here. We want to forecast for period 5. That's the missing one. So what we're actually going to do is change this where it says range and make this a 5. Okay, so for I in range 5, and then you can go forward a couple periods. We only have one missing piece there, so it doesn't really matter how far forward we go. We just need to fill it in. And so this loop here of code, what it will do is anywhere that there is missing information, it'll put in a forecast. So we just need to make sure our range covers the missing information. And since there's only one piece of missing information, it doesn't really matter how far forward we go. We could go 7, we could go 8. It really doesn't change anything. If you had other missing information, you want to make sure your range covers that span. So find the moving average from the complaint table, column complaints, 3-period moving average. And if, when you go and look at this spot, if it is NAN, if it's empty, then you're going to take that forecasted value and you're going to put it into the table. So let's run that. And then let's call the table. All right, so here was our original table, 60, 65, 55, 58, NAN, 40, 50, 52. Okay, so notice it looks the same and it didn't catch the NAN. So let's take this and let's make this a 4, because then we're looking at where complaints, where a period is 4. And let's run that. And so we can see here that we've now covered it and it's filled in that NAN. So we want to make sure that it is in that same location. And that's because the way we have it noted here is not by period, but it is by index. So this is CT, column complaints, and that second bracket is the index. So here index 4 is what's missing. So that's why this needs to start at a range of 4 to make sure it covers this piece. You could start earlier. So if I go back, for example, and I run this from here. Okay, so we have our missing NAN, right? We can see that that's index 4 there. And we run the loop here, and then we call the table. You'll notice that it also fills it in that way. So you can have this range just needs to cover the spot based on the index number where the NAN is. So not the period, but the index. And so we're ranging here, and that's because we have it defined by the index number. Okay. So now we have filled in the historical data, and that means that we can now go forward And to go forward, we need to forecast in the future. We can call our moving average definition here, and we can decide how far into the future to go. So this one here, this range, is based on the period. So we need this to be not 8, but we need this to be 9. So it's going to go from period 9, so forecasting the next period, period 9, and it's going to find the average and it's going to move forward. You'll notice here again, same as before, we're going to pull from the complaints from the complaint table. We're doing a 3-period moving average. Our columns are called period and complaints, and we're simply adding to that existing table. So we're going to take this table and we're going to add more to it. So let's run that. And we get our period 8, which was 8:52. And you can see here's 8:52, and now we've added 9 and 10, 11, and 12, and so on. So same thing, as we get too far into the future, becomes naive, because again, you're forecasting based on forecasting. You might choose, instead of doing a moving average, to do that weighted moving average, because yes, you're going to have some variability. So naive assumed no change. Moving average assumed a little bit of change. Weighted moving average puts more emphasis on the recent, so it allows for even more change. But these are all very short-term methods, which means you really can only forecast a little bit into the future before they become naive, and they really assume quite a bit of stability, as opposed to the trend methods that we'll look at in our next video. To do the weighted moving average, the approach is going to be very similar. So you're going to enter into your complaints, you're going to enter in your number of periods, you're going to turn it into a table so that you can see it. This one has no missing information at the moment. We're going to create a definition. This definition is called weighted moving average. Notice that it doesn't specify the number of periods, just the data itself. And that's because by the weights that you give it, it already knows the number of periods. Because if you give it weights of 0.5, 0.3, 0.2, it's 3 periods, because the weights have to add up to 100%. If you had a 5-period moving average, you could change, for example, maybe this is 0.3 and this is 0.2. So what's that? 2, 4. So that's 5. Maybe let's make it a little bit more. You could have it something like this. That's 6, 7, 8, 9, 10. Right? So that one is a 4-period moving average. Maybe you have 5 periods. Typically, you go with an odd number rather than an even number. So there, for example, would be the weights for a 5-period moving average. It knows it's 5 periods because you've given it 5 weights. Now, that's not really going to work for this data set here because you only have 4 periods historically. You don't have 5 data points to go backwards. So let's just change this back. 5, 3, and 2. So it's going to use these weights, make sure they add up to 100%. Okay, and again, it's going to then do that calculation for the weighted moving average. So you would change this only to change the weights portion. Otherwise, you could leave the definition as is for your own data set. So now we can define weighted moving average, and we'll call the weighted moving average definition, and all you have to do is give it the data itself. So notice there's no comma number here, it's just the data itself. When we do that, we can then pull the first weighted moving average. It takes 60, 65, and 55, and it puts 50% weight on the 55. So notice that this weighted moving average for the first 3 data points is a lower number than we did the moving average. That's because the moving average assumed they were all equally important, and so it came up with a higher forecast. Well, we want to go forward in the future, so we want period 5, which comes from taking period 2, 3, and 4, which here is going to be the weighted moving average, the next one in our series here. And so it takes 65, 55, and 58, puts more emphasis on the 58, least amount of emphasis on the 65, and we get a forecast that's 58.5. Okay. Well, in order to do the forecasting forward and make it easy to know which forecast is relevant to you, we can call that same loop that we had before. And with this loop, you'll notice that we are now calling the weighted moving average instead of the moving average. But the next two lines of code are essentially the same. It puts it into a data frame that matches the CT table, and then it just combines the two tables. That's really what this code here is. Now, we want to go from period 5 on into the future, and this is going by periods, so I actually need to change this to 5. And you can choose how far in the future you want to go. It's going to maintain those same weights. So it's going to put 50% on the previous period, and then 30% on 2 periods before, and then 10% before that. So we can run this loop. And we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see here. And we can see that our 58.5 is appearing right here for period 5, which is what we said it would be. And then you can see it keeps going. So notice that when we take 55 and 58 and 58.5, the three of them, and we more heavily weight the 58.5, we get 57.65. And then notice, just like the moving average, because you are using forecast to forecast, it becomes the naive approach very shortly after. Okay. When it comes to missing information with the weighted moving average, you deal with it the same way you did with the moving average. So here we have our complaints where we have one of the points that are missing and the number of periods, put it into a table. You can see that table when you call it. And here we have in period 5, index number 4, that NAN. So again, when you are going to fill in that missing information, you need to use the same method so you're not adding bias, so your assumptions aren't conflicting. And so here our loop is based on index location. We know that because it says CT complaints and then hard bracket I. That tells you it's the index for location of that column. And so we just need to make sure the range includes the index 4. So you can start it earlier, you can end it later. It just needs to cover 4. But what we're doing here is we're checking to see, is there an NAN? If there is, calculate the weighted moving average and put it in. So the difference between this loop and the loop before is that this says weighted moving average, and the input is only the complaints list, not the number of periods. You had already defined in the weighting moving average definition that it was 3 periods because you provided 3 weights. So when you run this and then call the table, you'll notice it's now filled in a forecasted value for period 5 or index 4. Okay, so we've used the same method, and now we can then do our loop to forecast into the future. We need periods starting with period 9 because we want to go into the future, and you can go as far into the future as you want. Notice here the difference between this and the previous moving average approach is we're simply calling the definition that's weighted moving average instead of moving average. And we run that and we output, and you can see here the forecasts into the future. Become naive over time, stop fluctuating. You fluctuate a little bit at the beginning as you kind of go back and forth between what's weighted heavily and what's not. Ultimately, they're going to stop changing as we get further into the future. So you can use the moving average. The weighting moving average allows for a bit more variability. In either case, if you have missing information, then you want to make sure you use the same method to forecast the missing information before you start moving forward into the future. In this video, we'll look at one last method, which is the exponential smoothing method. The exponential smoothing method is also forecasting very short term. And the way that the exponential smoothing method works is that it tries to adjust for how far off your forecast is. So the way the exponential smoothing method works is you need a method initially to start your forecast. Okay, so you need some forecast into the future. And then you need the actual value compared to that forecast. So you need to know how far off you are. And then you adjust that forecast by some smoothing constant, some number between 0 and 1, to take into consideration how far off you are. The larger the alpha, then you are taking into consideration the full amount that you were off. So for example, if alpha is 1, and then if we are off in our forecast, then we fully adjust the next forecast for the amount we were off. If alpha is 0, then we're not adjusting at all, no matter how far off we were. So it's a number between 0 and 1. So you might have an alpha, say a 0.4 or something like that, and then you adjust. But this means that it's a very short forecasting method because you really can only go one period in the future. You have to know what the actual is from the previous period in order to make the adjustment. So for example here, let's say that we have our complaints, and we have complaints for 8 periods. And let's just put it into a table so we can see it easily. So we're using our pd.data frame and list zip. So here's our table. No missing information, full 8 periods. Okay. Now, we want to forecast into the future. We are going to need essentially to add another column to this table for our forecasts. And so we're going to create another column in the CT table. So we do CT and then hard brackets and then quotes, forecast. That's the new column's name. And right now we're going to make it empty. So we're going to repeat NaN for the length of the table. That's what this says here. np.repeat. So we're using numpy. We're using a command called repeat. We're going to use the numpy NaN to signal that it's empty. And we're going to repeat it for the length of the table. So when I run that, I get this new column called forecast that's empty. And I do that so that we can start filling it, and then we can look at the previous forecast, compare it to the actual number of complaints, and then we can adjust. So for example, well, before as an example, we need to pick a starting point. You need an initial forecast. So just like in our thing here, we need somewhere to start. You need your first forecast needs to be based on something. So we could use an initial forecast that is the naive approach. So let's take period 1. The number of complaints was 63. So then for period 2, okay, which will be our index number 1, in column forecast, let's make it 63. So if I put this line of code here, so it basically says take our complaint table and at index 1, column forecast, make it 63. When you do that, you now get your table, and the only addition is 63 has been added to period 2, index 1. Okay, you have your starting forecast. Now we can see here that the forecast is 63. The actual number of complaints is 65. It's off by 2. So then we can adjust the next forecast by the fact that it was off by 2. So we need to create a definition for our exponential smoothing. That definition is going to have an A for actual, an F for the forecasted, and an alpha value. So we have our 3 inputs, actual, forecasted, and alpha, and this comes from this right here, actual, forecasted, and alpha, and that's the same forecasted. So you can see this formula here, F plus alpha times A minus F. So if we go back in, you can see that right here, F plus alpha times A minus F. That's going to give us the forecast, and we're going to return that forecast. So we define that. And so that means that we can then use our exponential smoothing. And here we want to have for our actual, we're going to use index 1, and we're going to use our actual here is in the complaints column. And then our forecasted is here, index 1, in the forecast column. And then let's use an alpha of 0.5. If you do that, you get a forecasted value here for period 3 that is 64. So it takes into consideration this was off by 2, and so it takes the old forecast of 63, and it's taking half of the difference, so half of 2 is 1, and that makes this one 64. So we're adjusting the old forecast by the difference, half the difference, and we get 64. Well, you want to keep going down the line, adjusting for how much each forecast is off. So we need to essentially create a loop that then takes those forecasts and complaints and looks at the difference and then takes half that difference and adds it to the previous forecast and keeps working down. So we're going to create a loop here. And our loop here is going to be based on the index. And we're going to take our forecast index. And we're going to start here, index 1. Here's our forecasted 63. And we want to move forward. Okay. So we're going to say, is that forecast empty? Is it NaN? If it is empty, then use the exponential smoothing forecast. So take the previous complaints, the previous forecast, adjust for the difference, and add it to it. You don't have to start here at 1, index 1. You could do 2 here, but you can't do earlier than 1 or else it starts filling in this previous section here. But we simply want it to start somewhere where there's a number or at the first NaN. If you start here where there's the first number, it'll say it's not empty, and then it goes to the next one. So you could start with range 1, you could start with range 2, and we can show that in just a second here. So it's going to then take it and fill it in, and I didn't quite go far enough, right? I had 8, and my range only went 7. So I can go longer here. And we can fill in those spots. I can clear this back out. Let's go back to the original. I'll change it to 2 and you can see what happens here. So let's just start this. C period CT. There's our table. We added the empty forecast. We add the naive approach that populated the 1 spot. We defined our exponential smoothing, and we'll have to run that again. If you make this a 2 instead, and we do it this way, and we go here, you'll notice that it accomplishes the same thing because it's simply looking for the empty ones, the NaNs, so it doesn't actually matter if we make that a range 1 or a range 2. You simply want to start it where there's already data or the first empty. Okay, and so we have forecasted forward. Now, the challenge with the exponential smoothing is that you have to have the actual from the previous period, so you can never really go more than 1 period into the future.